Hello, thank you for joining me. The question here says a metal of mass 3.6 kilogram is suspended from a spring balance. What is the reading of the balance in Newton with the metal in air, B with the metal in water, and C what is the density of a liquid when each reading gives 33 Newton? And we are given density of water, density of the metal, and we are given acceleration due to gravity. Now, for us to start with this, the very first question here, that is what will be the reading in air, is very simple. So I want to believe we can all do that. So I'll start by writing A. So the reading in air, which is the weight of the object now. So the weight of the metal, W, is equal to, let me call it weight in air, because that's the actual weight of the object. So I'll call it weight in air, W substitute A. And that will be given by the mass times acceleration due to gravity. So this is the formula for the weight of an object when you are given the mass. And that will be equal to the mass of the object as given to us in the question. The mass of the object is 3.6 kilogram, 3.6. And acceleration due to gravity is 10 as given to us here. So we can simply multiply those two values. And we say the mass, which is 3.6, multiplied by the acceleration due to gravity, which is 10. And that will give us the weight of the metal in air as 3.6 times 10 will give us 36 kilogram. Sorry, 36 Newton. Don't forget, weight is in Newton. So 36 Newton is the weight of the object in air. The weight of the object in air. Now, let's look at the second question. The second question says to find the reading of the balance of the spring balance with the metal in water. So when you now put the metal in water, definitely the reading will be less than this 36 Newton because it will experience upthrust. Upthrust is an upward force. So it will push the metal upward and it will make the weight to be less than 36. Now, before we can solve B, the first thing I would like us to do there is to find the volume of the metal. So in question B, let's find the volume of the metal. Don't forget that density is equal to mass over volume. So from there, I can say volume. When we make volume the subject of the formula, I'll just simply interchange these two to get volume. So volume will be mass over the density now, which is rho. Don't forget, this is symbol for density, which is rho. Now, we can substitute values, and we're going to get the mass of the object is 3.6. Don't forget, the mass given to us in the question is 3.6 all over the density of the object. It is here. The density of the metal, 9,000 kilogram per meter cube. So I divide by 9,000. So by the time we divide 3.6 by 9,000, it's going to give us the volume as 4 times 10 raised power minus 4 meter cube. So the volume is 4 times 10 raised power minus 4 meter cube. So that is the volume of the metal. Now that we have obtained the volume of the metal, it is very, very important that we go ahead and recall a very important formula. Now, when an object is immersed in a liquid, the density of that liquid is equal to the upthrust that object experienced, the upthrust in water, which is the loss of weight in water, or since it is water now, the loss of weight of that object in the water or in a liquid, as the case may be, all over the volume of the object. Take note of this very important formula, that the density of a liquid is equal to the upthrust of an object immersed in the liquid all over the volume of that object. Take note of this important formula. So from there now, let's substitute values. The density of the liquid, don't forget the liquid is water because we are asked to find its reading in water. So the density of water, you can see, is 1000. 1000. So we are going to substitute values now. So the density is 1000, that's density of water, is equal to the upthrust it experienced, which is what we are looking for right now, all over its volume. Don't forget, its volume is 4 times 10 raised to power minus 4. 4 times 10 raised to power minus 4. And then by the time we cross multiply, we're going to get the upthrust. Please don't forget, density is mass over volume. So this upthrust is in kilogram. It's like value in mass. In kilogram. So this upthrust is in kilogram, not yet in Newton. You can later convert it to Newton. But right now, in this formula, upthrust is in kilogram. So the upthrust in kilogram, let me put it now, will be equal to cross multiplying this, because this is like over 1. So U multiplied by 1 give us U. And then 1000 multiplied by this value is going to give us 0.4 kg. So this is the upthrust in kilogram. But what about the upthrust in Newton? Don't forget, to convert kilogram to Newton, or to convert mass to Newton, you simply multiply by acceleration due to gravity, 10. So don't forget, to calculate upthrust in Newton, you multiply that upthrust in kilogram by 10. And that will give us the upthrust in Newton as 0.4 times 10 is 4 Newton. So this is the upthrust in Newton, the upthrust experienced in water. Then now, don't forget that upthrust, because we are asked to find weight in weight in the water. Don't forget that upthrust is loss in weight. So the weight in water now, I can say therefore, the weight in water, let me use W subscript W now. W subscript W. So the weight now will be equal to the weight in water. Weight in air minus the upthrust. The weight in water will be equal to the weight in air minus the upthrust, because upthrust is the loss in weight. So weight in air minus the upthrust will give us the weight in water, because in water it has lost some weight, and that is this upthrust. So getting the reading now, which is the weight in water, the reading of the spring balance will be the weight in air, which is what we have obtained before at the beginning. The weight in air is 36 Newton. You can see it here. So the weight in air is 36 Newton. So we can take that value now, 36 Newton. That is 36 minus the upthrust, which is 4. So that will give us the weight in water. That is the reading of the balance in water as equal to 32 Newton. So that is the answer to that. Now, let's go on to question C. I would like to solve question C on this side. Let me rule a line here so that I can solve it on this side. So let me just rule a line here. So now, I'll call this question C now. So C. In question C, we are asked to find the density of a liquid. So the question says, what is the density of a liquid when each reading gives 33 Newton? So when it is immersed in a liquid, when that metal is immersed in a liquid, its weight or the reading in that liquid is 33 Newton, the reading of the balance. So we have to find the density of the liquid. For us to do that, first of all, we have to calculate the upthrust. So I'll say the upthrust it experienced in that liquid is equal to, don't forget the formula, upthrust is weight in air minus the weight in the liquid, which is loss of, don't forget, upthrust is loss in weight. So it weighs a particular value in air. In the liquid, it weighs another value. So the loss in weight, which is weight in air minus weight in liquid, give us the upthrust. And so that will be equal to the weight in air, as you can see, is 36 Newton. So that will be 36 Newton minus the weight in the liquid. As given to us in the question, we are told that it weighs 33 Newton in the liquid, 33. So we subtract that value. So minus 33. So that will give us the upthrust. This time, don't forget the upthrust is in Newton. 33 Newton, 36 Newton minus 33 Newton will give us 3 Newton. But we need to find the upthrust in kilogram before we can use it in the density formula. So upthrust in kilogram now will be equal to 3 over acceleration due to gravity, which is 10. Don't forget, weight is equal to mg. So when you are looking for the mass, you simply divide both sides by g, divide both sides by g. So that's why I'm saying 3, which is the weight, divided by 10, which is the value for acceleration due to gravity. And that will give us the upthrust in kilogram as 0.3 kilogram. So this is the upthrust of the metal inside that liquid. So now, we can now go to the density formula for that particular liquid. Don't forget what I gave you. That formula is very, very important. That the density of a liquid is equal to the upthrust it experienced in that liquid. This time, don't forget the upthrust must be in kilogram, all over the volume of that solid in the liquid. So this metal now, so this is the volume of the metal. This is the upthrust it experienced in the liquid, upthrust in kilogram. And this is the density of the liquid. We have to find the density of the liquid. So we simply say the upthrust it experienced in kilogram. Don't forget this upthrust here must be in kilogram. So that's why we converted to kilogram. 0.3 all divided by the volume of the solid. Don't forget, we have obtained the volume of the solid before, and that is 4 times 10 raised power minus 4. So all divided by 4 times 10 raised power minus 4. So by the time we divide this value, it will give us the density of the liquid as equal to 0.3 divided by 4 times 10 raised power minus 4 is going to give us 750 kilogram per meter cube. So this is the density of that liquid. And that's the final answer. Hope you enjoyed this video. Please don't forget to like, share, and join for more videos. Thank you for watching.